Welcome dear students. My name is Shahid Mahmood. Today I will explain Unit 1 May-June 2023 chemistry paper from Pearson Edexcel. So let's start with the paper. Question 1 is which compound has the greatest covalent character? 4 ionic compounds are given here. In the ionic compound, positive ions and the negative ions. In the positive ions, we see the polarizing power, and from the negative ions, we see the polarizability. The factors which affect the polarizing power of the positive ion is their size and charge. So smaller the size and more charge, those positive ion will be more polarized. While the negative ion having bigger size and more charge, they will be more polarizable. If the negative ion is more polarizable, the positive ion is more polarizing power, there'll be more distortion and there'll be more covalent character. So in this case, if we look at here, so down the group, the fluorine, chlorine, bromine. So bromine has the bigger size, and the magnesium size is smaller than sodium, and the charge is +2 and here is +1. So the magnesium size is small, and there should be more distortion between magnesium and bromine, and there'll be more covalent character. So here our option is option A. We can explain this question by another way also. Like, see here, in the ionic compound, if the electronegativity difference between the positive and negative ion is more, there is more ionic character. But if the electronegativity difference between the positive ion and the negative ion is less, so there will be more covalent character. Now, in this case, magnesium and sodium is used. So if you look at here, so sodium to magnesium, the electronegativity is decreasing. And this is not only sodium to magnesium, across the period, left to right, electronegativity decreases. While from top to bottom, electronegativity is increasing, while top to bottom, it is decreasing. Now, bromine has 2.8, while magnesium has 1.2. So 2.8 and 1.2, so the difference is 1.6. So if we here find the difference of the difference, and this has more covalent character. In this case, if you don't know the electronegativity values, it's okay. It's not the big deal. At least the trend you must know because you study this in Unit 1, that down the group electronegativity is decreasing while across the period it is increasing. So automatically you will get the idea that magnesium has lower than sodium and their difference will be the least one and it has more covalent character. The next question is which has the smallest ionic radius? All these ions are given here are isoelectronic. Isoelectronic are the ions which have same number of electrons. In this case, if you look at here, fluoride, magnesium, sodium, and oxide, they have same number of electrons, but the number of protons, which is their atomic number, are different. So look at here, the 12 proton, it strongly attract the 10 electrons. So the size will be very, very small. And if the protons are the least, the minimum one, so it will loosely attract the electrons and the size will be the biggest one. So here you can generalize that if for the isoelectronic, more positive, so more smaller, and more negative, so more bigger. So in this case, the smallest ionic radius is for magnesium ion. Question 3, the first 7 ionization energies in kilojoule per mole of an element are shown. Values are given. In which group of the periodic table is this element located? You see here, these are the consecutive ionization energies values given. Normally, the second ionization energy is double to the first. The third one is double or less than that to the second one. And it is increasing. But you will see where is the big jump. So the big jump you can see here. So you have to draw the line. Because this is 6,000, while the sixth ionization energy is 21,000. So this increase is more than double and triple time. So here 1, 2, 3, 4, 5. And this element is in group 5. Question 4, what is the electronic configuration of an oxygen atom in its ground state? Here they give you a condition that ground state. So if you look at here, oxygen atomic number is 8. When you do the configuration, 1 is 2, 2 is 2, and 2p2. So you can do its box configuration, but you have to read the question a bit carefully. You look at here, like here is also two lone pair, and here is also single pair. These two are given in pair in the same direction, so it is wrong. And this one is given opposite direction. Electrons in an orbital always have opposite direction. So the correct option is option D. Question 5. Which property shows a general decrease across the periodic table from sodium to chlorine? So down the group, atomic size, atomic radius increases, while across the period it is decreases. But look at here, this is, they give the condition again, sodium to chlorine. So if you look at here, so sodium in period 2, then magnesium, then aluminum, then silicon, then phosphorus, then sulfur, and then 3. Across the period, atomic radius is decreasing due to increase in nuclear charge or number of proton. So the first option is the correct option. So no need to go through B, C, and D. So the correct option here is option A. Question number 6. The first ionization energy of sulfur is lower than that of phosphorus. Which is the best explanation for this? Now, whenever you see the question best explanation, so there could be more than one option correct, but you will opt the best one. So see here, one is sulfur and one is phosphorus. Now, this is a little bit common question. Phosphorus atomic number is 15, while sulfur is 16. 2p6, 3s2, and 3p3. While this one is 1s2, 2s2, 2p6, 3s2, and 3p4. Now, if you focus on this, so here in phosphorus, there are 4 electrons here. So 1, 2, 3, and 4. So here is this electron pair in the p orbital. Now, if you read the options, the atomic radius of sulfur is greater than that of phosphorus. So this is not correct, because across the period we just studied in the previous question that the size decreasing. The electronegativity of sulfur is greater than that of phosphorus. Now, this is correct option, but it has nothing to do with the ionization energy. The repulsion between the outer electrons, the repulsion between the outer electrons of sulfur is greater than that of phosphorus. Yes. So here is electron pair and there is electron pair repulsion. And for this reason, option C is the correct option. Question 7. 1 kilogram of seawater contains 64 milligram of bromide ions. Relative atomic mass of bromine is given. Avogadro's constant is given. Option A is, what is the concentration of bromide ions in parts per million by mass? So if you look at here, if you take the seawater, 1 kilogram, so the bromide ion which is present are 64 milligram. The units are given in masses, but we have to make them in equivalent units. 1 kilogram, you know that it is equal to 1 million milligram. While this is already milligram, so we reach to our answer that in 1 million milligram, bromide ion is present 64. So the option is option B. So just to change their units and bring them to the same unit, you will reach to the answer. Part B, how many bromide ions are in 500 gram of the sample? So you see here, in this question, they already gave us a standard that 1 kilogram of seawater contains 64 milligram of bromide ions. So we already know that the seawater, which is 1 kilogram, has the bromide ions 64 milligram. Now, if we change into grams, so 1000 gram of the seawater contains 0.064 gram of bromide ion. So 500 gram will have how much? Now, this is 500 is a half of it. You can solve 500 times 0.064 divided by 1000. So you will find the mass of bromide ion, which is 0.032 gram. Now, to find the number of bromide ions, first we will change this into moles. So 0.032 gram divided by its MR, which is given to us in the question 80. So we will find the moles. Now, this you will times with the Avogadro's number, and you will reach directly to the answer. And the answer is 0.0024 times 10 raised to the power 10 raised to the power 20. And the correct option is option A. Question number 8. 0.15 mole of aluminium is added to 120 cm cube of 1.50 mole per dm cube hydrochloric acid. So two reactants are here, aluminium and hydrochloric acid. Aluminium is 0.15 mole, so it's okay. But hydrochloric acid is volume and concentration. Volume is 120 cm cube, while concentration is 1.50 moles per dm cube. To find the number of moles, C times E by 1000. So we will find 1.50 times C times E and by 1000. So here the number of moles of this is 0.18 moles. This is the given number of moles of the acid, and for the aluminum it is 0.15 mole. Now, first of all, we have written, and then from the excess reactant, how much of that reactant is left unused, unreacted. So look at here, this is 2Al plus the acid gives hydrogen ion, and this is hydrochloric acid. So 1 mole of HCl will give 1 mole of hydrogen ion. Now, 6 mole of hydrogen ion needs 2 moles of aluminum. This is from the balance equation. So the number of moles which we get from the given data, this will need how much aluminum to react. So X is equal to 2 times 0.18 divided by 6. Now in this case, we will get 0.06. Aluminum we need 0.06, while aluminum we need 0.06 mole, while the given amount is 0.15 moles. So the remaining which is left unused and unreacted, that is 0.09 moles of aluminum. And our correct option is option B. An organic compound contains 24.8% of chlorine by mass. Atomic masses are given. What is empiric? Carbon, hydrogen, and chlorine in order, and write their percentages over here under each element. Now, let's suppose the compound is 100 gram. So carbon is this much gram, hydrogen is this much, and chlorine is 71.8 gram. First of all, we will divide this by the respective atomic masses. So to get the number of moles. Now, when we do this compound, so when we get the number of moles, so after that, this is 2.1, this is 4.0, and this 2.02, 2.02, and 2.02. So this almost we get 1, here get 2, and here get 1. So carbon is 1, hydrogen are 2, and chlorine is 1. And this is option B. The next question is, which solution contains the smallest number of ions? All these are given solutions. So volume is given, concentration is given. Now, they are only asking that which one of these samples contain the smallest number of ions. We are not supposed to find out the exact number of ions. So we will simplify our method. Like, see here, whenever we are collecting the number of ions, the number of atoms, so we use 3 boxes. You will see this method in other my videos also. The first box we always use to calculate the number of moles. Then when we multiply this by the Avogadro's number, so we get the number of molecules or formula units in the case of ionic compound. And when we multiply this by the number of atoms or ions, you also know that if we have 1 mole of some substance, element or compound, so it has 6 times 10 raised to the power 23 particles. But if you take double moles of this number of particles, that means smaller the moles, smaller will be the particles. Bigger the moles, bigger will be the particle. This idea we have to keep in second box, because we are not supposed to find out the exact number. We will just find here the number of moles of the ions. The number of moles of the ions. So in the first case, the volumes are here, the concentration is here. Even here, all are given in cm³. So no need to change the volume into dm³. The concentration is 0.06, then times 500. So this will be the number of moles. Here I'm skipping the step that divide by 1000. And look at here, calcium nitrate. So nitrate are 2 and calcium is 1. So the total number of ions are 3. Now, by doing this method, we are finding simply or roughly the number of moles of the ions. In this case, I'm getting 90. The second one is 0.09 times 500 times 2, because potassium and iodine, they have 2 ions. Again, I'm getting here 90. 0.12 concentration times volume 250 times. Again, this is barium and 2 chloride, so total ions are 3, and I'm getting again 90. The last one is option, definitely, because if it is 90, 90, 90, so let's see here, there is 0.09 times 250 and times, this is 2 ammonium ion and 1 sulfate, so 3. Here my answer is 67.5. So if this is roughly the number of moles or smaller number, so definitely it contains the smallest number of ions, and our correct option is D. Dear students, you have to save the time in the multiple choice questions. So if you will solve the question, so you will find the easy way how to reach to the answers. I understand here that here I did not divide volume by 1000 and I did not change the volume into DMQ. The reason is here we are not supposed to find the exact number of ions, just only to reach to the answer which has the smallest number of ions. I hope that you will understand this. Question number 11. It's a simple question. A piece to a microscope slide. A few crystals of filter paper. The filter paper is connected to a DC supply of 20 volts. What colors are observed on the paper after a few minutes? Now, CrO4, this is -2, this is +2. You know that copper has blue color in aqueous solution while chromate 6 has yellow color. Now, if you look at here, this is +2 charge, so it will go to the minus side, minus electrode, and this is negative ion, so it will go to positive electrode. So it means the yellow color will go to positive side, the blue color will go to negative side. This side is positive, color will come here. The option is option D. Question 12. The melting temperature of beryllium is greater than that of statement. Now, beryllium, magnesium, calcium, strontium, barium, and radium. Down the group 2. These are alkaline earth metals. Are alkaline earth metals, so we will explain this on the base of metallic bonding. And you must know what is metallic bond, that the electrostatic force of attraction between the positive ions in the sea of delocalized electron. If the attraction between the positive ions in the sea of delocalized electron is stronger, it will need more energy to separate or to break the bonds while having higher melting point. And if this force of attraction is weaker, it will need less energy to separate the ions from the electrons and will having low melting point. Now, down the group, you see here the size of the ion is increasing. So beryllium ions are smaller than barium ions. So you get the answer in the first option. Beryllium ions are smaller than barium ions. Yes, is the correct option. Question 13. Which molecule has the largest bond angles? Dear students, in this topic, the shapes of molecules and then their bond angles, you must do a proper practice. See here, the first compound is BF3. So quickly you work out the question. Boron is from group 3. It has 3 bond pairs in the end. CF4, this is carbon is group 4, surrounded by the 4 bond pairs. It is tetrahedral structure and the angle is 109.5 degree. H2O, it has 2 bond pairs. Oxygen has 2 bond pairs and 2 lone pairs because it's a group 6 element, and the angle compound is ammonia. And ammonia, nitrogen is surrounded by 3 bond pairs and 1 lone pair. And here the angle is 107 degree trigonal pyramid. So the largest bond angle, is 120. So the largest bond angle is BF3. And the smallest bond angle will be definitely H2O, because they may ask you question on that side also in another question in the paper. Which molecule is polar? Now, for the multiple choice, you can quickly reach to this answer by following these 2 rules, because these 2 rules mostly work, not in all the situation, but in most of the cases, it works. Like if the central atom has no lone pair of electron, and the second rule is that the central atom is bonded to same atoms. In these both condition, if it is followed by a compound, so it will be non-polar. Okay, but here we want to reach to polar molecule. Now, the first compound is carbon dioxide. It's a common example. Carbon is surrounded by the bond pairs only, and there is no lone pair, so this is non-polar. The second compound is SF6. Now, in SF6, it has octahedral structure. Sulfur is in group 6, and it is surrounded by 6 bond pairs, and there is no lone pair left. All the surrounding atoms are same, so again, this is non-polar. Sulfur, it has lone pair now. So this is the first example comes. Both oxygens are same, surrounded atoms are same, but they are saying no lone pair, but there is lone pair. So this is polar molecule. While the last compound is SiCl4. So silicon is atoms are same, so it is also non-polar. So the correct option here is option C. The reaction of methane with chlorine is a free radical. If we look at here, in the initiation step. It completes in 3 steps. This mechanism completes in 3 steps. The first one is initiation step. The second one is propagation step. In propagation step, one of the free radical which is highly reactive will react with methane and will snatch one hydrogen to get step. It will make compound HCl. Now in CH4, 3 hydrogen left and it becomes free radical. This CH3 free radical is highly reactive. It will now react with normal molecule which is less reactive. This time CH3 free radical is highly reactive. It will Cl and the leftover will become the free radical. Now to come to termination steps. In the third step, termination step, 2 of the free radical will join together to give a neutral molecule. Now, so far, if you see the above 3 steps, we have chlorine free radical, we have CH3 free radical. So any of these 2 free radicals may join. Like the first one, the possibility a radical may join with chlorine free radical to give chloromethane. And the last option here is in the given above steps, that maybe we get ethane. So if you look at here, or this also you can write C2H6. So this is here, okay. This CH3Cl, it is here. ClCl is here, but only this equation or this CH3 dot and H dot CH4, it is not here, so our option is C. For your information, you must keep in mind that hydrogen free radical doesn't form through carbon. Due to the smaller size of hydrogen, this bond is very strong bond. Very strong bond. And the UV light, which is used, a condition over here, the UV light energy is not capable to break this bond, so hydrogen free radical never forms in the free radical substitution reaction. Question 16, the repeat unit of a polymer, but you will go a bit in reverse direction, that from this polymer, you have to draw its monomer first. Now to draw the monomer, I draw the structure again to give the idea. This one and this one, and you will put a double bond in the center, okay? After this, you will just give the proper naming according to the IUPAC system. So select the longest chain. So this is 1, this is 2, this is 3, and this is 4. Double bond is at second position, and this is a branch. So you can say 2-methyl and but 2-ene, and you will reach to your correct option. 2-methyl but 2-ene. Option C is the correct option. The next question is, what is the IUPAC name for the compound shown? This time they give us the skeletal formula. So see here, the 2, carbon 3, carbon 4. It means double bond is at first position, so 1-ene, okay? So this is 1-ene and this is 1-ene, so we will focus on these two only. Option A and up is this methyl group. So 2-methyl and 2-methyl, both are 2-methyl, so we cannot even reach to the answer. But the stereochemistry, the isomer, bromine is here. If you see here, we don't mention in skeletal formula the hydrogen, but here the hydrogen is bonded. Hydrogen atomic number is 1, and this 1 carbon, and here this side there are 2 carbons, so this is priority group. In this case, the 2 priority groups are present at the opposite side of the double bond, so this is E isomer. Now this is E isomer, so at 1 position bromine is bonded, so E 1 bromo, then 2 methyl, and but 1-ene. So our correct option is option A. The skeletal formula of cyclohexane 1,4-di in this molecule is, now all single bonds are sigma bonds, while all double bond contain 1 sigma, 1 pi. So during this cycle, see here, this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. But 6 is not enough because these points, they are carbon. So carbon make 1 hydrogen here, 2 hydrogen here, 1 hydrogen here, and 6 hydrogen, sorry. So 7, 8, 9, 10, 11, 12, 13, 14. So there are total 14 hydrogen, there are 14 single bonds. Because the carbon hydrogen bond is single, so 6 single bonds are inside the ring, while 8 sigma bonds are outside the ring, and the total number of sigma bonds are 14. In this case, the last part, 1 point used to cyclohexane by reacting it with hydrogen gas. The molar volume of a gas is 24.0 dm³ per mole at room temperature and pressure. Molar mass is given 80. What is the minimum volume in dm³ of hydrogen needed at RTP? Dear student, you already know that this 1,4-diene contains 2 double bonds. cyclohexa 1,4-diene. If there are two double cyclohexane, so for each double bond, we need 1 mole of hydrogen. There are two double bonds, we will need 2 moles of hydrogen. Now the question bit simple. Simple in word. Like, what is the minimum volume in dm cube of hydrogen? So under hydrogen, write volume and question mark. We are calculating it. While the 1,4-diene, cyclohexa 1,4-diene is given to us 1.60 gram. Dear student, in the stoichiometric calculation, as these are the ratios in which they are reacting with each other to get a product. So this is direct method. This is volume. So you need to write the volume of hydrogen over here in the balance equation. They already told us that the 1 mole volume is 24 dm cube. So this is 2 moles. So 24 times 2. So this will be the volume of 2 moles of hydrogen. Why we write volume here? Because this is volume. And this is mass. So this is 1 mole and the 1 mole mass is 80. So this is 80 gram. Now you cross multiply. So volume is equal to 1.60 times 2 times 24 divided by 80. And we will get the answer 0.96 dm cube. And our option is option C.